We are on the 6869 review packet. Starting with side 6-8. 1 through 6, we're going to rewrite the equation in standard form, which is ax plus by equals c with integer coefficients, integers being whole numbers, either positive or negative, but we cannot leave fractions or decimals. So basically we need x and y on the same side of the equal sign, some other whole number on the right side, and whatever the coefficient is for x and y, they need to be whole numbers, which again are called integers. So for number 1, this is given to us in slope-intercept form, y equals mx plus b. We need to rearrange this so that x and y are both on the same side. So this negative 3x needs to come on the other side and join up with the y. And so we're going to eliminate it from this side by doing whatever gets it to 0. So a negative 3x, we're going to add 3x. To cancel it, do it on the other side. And when you put them in this order, we got to put the x up front. So it's going to say 3x plus, we have a positive y, equals, and this leftover minus 7 is going to stay as a negative 7. Okay, number 2. If you want to, you can eliminate the fraction first. We talked about earlier how in some cases we want a to be a positive number. The directions here, they're not specific about that. They just say they need to be an integer, which includes positives and negatives. So since we're not concerned about a being positive or negative, just a whole number, it doesn't really matter what order we do this in. I'm going to go ahead and multiply by 5 right now to eliminate the denominator. If you only have one fraction, you just look at the denominator. That's what you're going to multiply by. Everything gets multiplied by that. So 5 times y is 5y. 5 times this will eliminate the denominator, leaving you a 2x. And 5 times 14 is 70. And now I need to get x and y on the same side of the equal sign to make this standard form. So I'm going to minus 2x from both sides, which will eliminate it. And I'm going to put it in the correct order with x first. So since I'm subtracting it, it's like a negative 2x. That's a positive 5y, so it's plus 5y. And I still have 70 on this side. Remember that these are equivalent equations. Okay, the same values that you plug in for x and y will make them both true. Okay, if you graphed them, it's the same line. Okay, so we're not changing the line. We're not changing the equivalency of the equation. We're simply putting it in a different form. Number 3. So I do want this x10 up on the other side, but I'm going to go ahead and find an integer coefficient. So since there's only one fraction to clear out, you just multiply by the denominator. Everything gets this number you're multiplying by, though. So 3 times y is 3y. 3 times 8 is 24. It's going to be a negative. The 3's cancel, so leaving me just a 1x, which is just an x. Got to go to the other side with it now to put it with the y, so I'm going to add x over here. And putting it up front, it's x plus 3y equals 24. Now number 4. An integer is a whole number, so we don't have any fractions, but we do need to get rid of this decimal. One way to get rid of a decimal is to multiply by 10, and it will slide over one decimal place. So we'd have 20, 25, and 90. But to keep the numbers small, fully simplified, what I want to do is just times this by 2. Now, it's not incorrect to multiply by 10. Perfectly fine. But I know if I double 2.5, think about $2.50. If you take that twice, you have $5. 2 times 250 is just 5. Okay, so I'm going to go ahead and distribute here. It's 4y minus 5 and 18x. Now, in this case, I'm going to go ahead and leave my negative 5 over here, and I'm going to move the y. We've been moving x, but in this case, I'm going to move y over here, so minus 4y. Get it on the same side with x. So I'm left with negative 5 equals 18x minus 4y, and this is perfectly good. You'll notice on the answer key, it said negative 18, and I have positive 18. It said positive 4, I have negative 4, 5, negative 5. So all 3 of these terms are opposites. If I went ahead and took mine and multiplied it by negative 1, as long as I multiply everything by negative 1, I'm not changing the equivalency of this equation, so they would actually be equal equations. And so these are equal to each other, and one form is not better than the other in this case, so either one is fine. Number 5, x and y already on the same side. I just need this 3 to get out of here, so I'm going to add 3. to the opposite side. That's going to give me 3 on this side. I still have an x and a y. I want to put them in the right order, so I'm going to put x up front. It's a minus x, which is like a negative x, so I put that up front. It's a positive y, so it's like a plus y, and it looks like this. And number 6, I'm going to go ahead and clear out this, so I'm going to multiply by 9. So 9 times 30 is 270x. The 9's cancel, leaving me a 1y. And 9 times 70, think about 9 times 7 is 63, so 9 times 70 is 630. All I got to do now is move the y on the same side as the x to get this in standard form. Put x first, so 270x minus y equals 630, and I'm in good standard form. Okay, number 7, in the game of paper football, so not regular football, paper football, you get 6 points for a touchdown, just like regular football, only 1 point for a field goal, so not 3 points, just be careful. 1 point for a field goal. Marco scores X number of touchdowns, so for every touchdown he gets 6 points. So we're going to write an equation here in standard form. So it's 6 times the number of touchdowns, and y field goals. For every field goal, you're going to multiply by 1, so it's just 1y. It's going to be a total of 20 points. So there's my equation. 6 times the number of touchdowns plus the number of field goals has to equal 20. Give 3 solutions to your equation from part A, so numbers we could plug in. So potentially he could get 0 touchdowns. If he got 0 touchdowns and had 20 points, that means he kicked 20 field goals because they're worth 1 point each. What if he scored 1 touchdown? That would be 6 points. So he needs 14 more to come from field goals. So that would be 14 of them. And what if I plug 2 in, 2 touchdowns? That's 12, so he's going to have 8. It only asked for 3, but you could have gone with 3 touchdowns. 6 times 3 is 18, and so that means he had 2 field goals. And those are your only options because you can't score a half a touchdown or anything like that. So it's either 0, 1, 2, or 3. If he scored 4 touchdowns, he'd be over 20 points. So these are your only 3 options here. Okay, down at the bottom, one of the strategies that we can use to graph is to find the x and y intercepts. When you hit an axis, one of your 2 values is 0. When you hit the x-axis, the y is 0. When you hit the y-axis, the x is 0. So we can go ahead and plug 0 in for either x or y, and it will give us the intercept. Especially when it's in standard form, it's nice and easy, because if I plug 0 in for x, so if I do that, I'm going to have a 0 for x. What happens to y? So this basically clears out because it's 3 times 0. I have 8y equals negative 24, so I would divide by 8, and y equals negative 3. So I have the point 0, negative 3. That's my y-intercept. So if I'm counting by ones here, my y-intercept will go right here. And if I plug in 0 for y, 8 times 0 is 0, so this goes away. I'm left with 3x equals negative 24, so I divide by 3, and x equals negative 8. So these are my intercepts. These are the actual points. I don't have 8 lines here, so I would have to count by 2's. So 2, 4, 6, 8, and of course these are negative. And so this point would go right here. And when you graph that line, you're just going to go ahead and draw a line through it. And if you counted by 2's here, maybe you counted by 2's here. So then you're negative 3. You'd go 2 and then have to go to 3, and that's fine. But your y and x do not have to count by the same amount. So these can count by 2's and these can count by 1's. Okay, it doesn't matter. Number 9. Same idea, plugging 0 in for x, I'm going to have negative 2y equals 10. So when I divide that, y equals negative 5. So that's 0, negative 5. And if I plug in 0 for my y and find my x, I'm left with 5x equals 10. So that's 2. So I'm going to go to 2, 0, and graph my line. So flipping over to 6, 9, we're going to graph all the points to satisfy these inequalities. When we graph an inequality, a linear inequality, it's going to be a line, and then one side of that line will be shaded because it's not the line that shows all our possible solutions. It's everything less than or greater than that line. So we're going to shade part of our graph. So starting with these two very specific ones, if it helps, think of it like an equal sign at first when you're going ahead and trying to graph it. So it says x equals -3. So that type of graph, x value is always -3. So I'm going to hit the x-axis at -3, and it's never going to leave that. So the y values change, but the x value does not. Now, before I drew that, I should have took a look and made sure. I got lucky. Okay, there's an equal sign here, so this is a solid line. When I do not have an equal sign underneath, I do need to draw a dotted line. Okay, so this is x equals -3, and if I say greater than, sometimes we struggle on these vertical lines. Well, which one's less than, which one's greater than? Think about your x values. Where are the greater x values compared to this line? That would be up here, and so everything needs to get shaded right there. So on number 2, now it's y less than 7. So think of it like y equals 7. You're going to go to that spot on the y-axis. Now we're going to have to count by 2's to get to 7. So 2, 4, 6, 7 is going to be right here. And it's going to be the line that always stays at y equals 7. X value will change left to right, but the y value stays 7. And this is a less than, not a less than or equal to. So when I draw this line, it does need to be a dotted line. And everything less than, we're talking about y values, everything less than 7 is down here. Okay, number 3, in a perfect form for us to put this on a graph, intercept is -5. So right here, slope is 3, so up 3 over 1. I do not have an equal sign here, so this should be a dotted line. And now it says greater than, and this is in terms of y. So find the spot that we cross the y-axis. Think about the numbers that are greater than that number. That's going to be everything up here. Or if you look at your line the way it's tilted, everything above it, since it's greater than, will be all of this. Number 4, it's not given to us in the perfect y equals mx plus b form, but y is isolated by itself, which means I do have my slope and my intercept, so I am starting at 2 and using my slope of up 1 over 2. I'm going to reverse it. I'm going to go down 1 left 2. I do have the equal sign, which means the line is included in my solution. To show that, I draw a solid line. It says y is less than. Everything less than is going to be underneath this line, shaded like that. Okay, I get to number 5, and I'm not in that nice form where I can just start graphing. So I need to get it there. I'm going to go ahead and minus 3x from both sides. So I have 4y less than -3x plus 10 dividing by 4. Now this is not dividing by a negative, so I'm not going to flip my inequality. It's going to stay less than. It's -3/4 x, that's my slope. And now it's 10 over 4. So 10 over 4 does simplify to 5 over 2. And if you're curious, now that's my intercept. Where do I find 5 over 2 on the graph? If you divide those, 5 over 2 is 2.5. So I'm going up to 2.5 right here. And now be careful. From that point, I have to go down 3 and then over 4. So down 1 would be all the way to the middle here. Down 2, down 3. It's right there. Okay, and then over 4, 1, 2, 3, 4 should be right there. This should be a dotted line. And now it says less than, and so we are going to shade all the y values underneath, or less than all of those y values. All right, number 6, again, I need to get this in good form. I'm going to minus 9x, trying to isolate my y value. So it's going to say -9y. Now when I see that, I know I'm going to have to divide by a negative. So this will flip and become a less than. I've got -9x plus 63. When I divide by -9, dividing by a negative, this has to flip. So y is less than or equal to. 2 negatives are going to make a positive. So it's just a 1x. And then this is going to be a negative. 63 divided by 9 is 7. So my intercept is negative 7. My slope is 1. So 1 over 1, up 1 over 1. I do not have 7 lines. I got to count by 2's. So negative 2, 4, 6. One more would be 8, so 7's in the middle. Up 1 is still going to be between, over 1. Up 1 between, over 1. Up 1, over 1. Up 1, over 1. This should be a solid line because of the equal sign underneath my less than. And since it did flip and it now says y is less than, I need to shade underneath of this. So I'm right down here. Okay, last one, number 7. Box of tea, there's 20 bags. If you make a cup, it requires 1 tea bag. And if you make a pitcher of tea, it takes 4 tea bags. You only have a total of 20 bags here. So we're going to write an inequality that gives the maximum number of cups and pitchers that can be made with 1 box. So I'm going to use 1 bag per cup, so that's just C. So if I take my number of cups plus my number of pitchers, okay, which require 4 tea bags, so for every pitcher, which is P, I'm going to have 4 tea bags. If I add these up, number of cups that I make, number of pitchers that I make, it's going to tell me how many tea bags I've used, and I can only use up to 20. I can use less, but I can't use more. So it needs to be less than or equal to 20. I can use 20 right on the dot, so you have to have the equals, or I can use less than. So we're going to give 2 possible combinations. Now we can come up with combinations that equal it exactly. For instance, if I made 0 cups and 5 pitchers, if you plugged in 5 times 4 is 20, you would use all 20 for your pitchers, as long as you had no cups. You could also say, what if I used 4 cups? That would be 4, meaning I still have 16 bags left over. So I could still make 4 pitchers, and that would hit exactly 20. But you could also just come up with numbers like this. You can make 1 cup, right? So anything that's less than or equal to 20 is going to work. So 1 cup or 1 pitcher, anything like that is still going to give you a solution that is less than 20.